So now let's learn something about how to actually take this protractor and measure some real angles. So let's turn to our 1.07 notes section, and the objective for this lesson is to identify angles, classify angles, use the angle addition postulate, and the definition of angle bisector to construct angles and measure angles with a protractor. Okay, so we're going to go ahead and learn how to use this protractor. Now, notice the protractor is transparent, and there's a reason for that. Okay, so let's focus in on the first problem, and let's go ahead and let's place the protractor. Now what you want to do is you want to line up the origin of the protractor, this hole, with the vertex of the angle you're measuring. Okay, so we're going to put this right on top like a bullseye. Okay, we're going to center the origin and the vertex, just like about that. That's the first thing you want to do. The second thing you want to do is this baseline, this line here. You want to line it up with one of the sides of your angles. Okay, so let's center the bullseye. Let's line up this line, the baseline, so it's right on top of one of the angles. Raise one of the sides of the angles. That's pretty good. Okay, and then we know this is an acute angle, right? It's less than 90 degrees, so we expect to use the inner counterclockwise scale. Remember, we said that's the one we normally want to use. If you notice, the outer scale is going to give us a reading of somewhere around 135 degrees or 133 degrees, where we know this is an acute angle, so we know we have to use the inner scale. Well, let's take a look at the inner scale. To measure the angle, we have to look at exactly what mark the arrow is pointing to. Okay, now we've got a rough scale right on this edge, and then we've got a finer scale a little bit further above it. Well, we're going to want to use that finer scale because we want to know exactly how many degrees this angle is, and this line is not quite long enough, so we're going to have to lengthen the line a little bit. But before we even do that, let's get an idea of an approximate measure of this angle. This is 40 degrees over here, and this is 50 degrees over here. So this is 45. Looks like we're around 47 or 48 degrees for this angle. Okay, so that's at least giving us a rough idea. One of the things that you may have to do, especially if you have a large protractor like me, and the angles are not that large, you may have to lengthen the angle a little bit. You want to make sure you're going right along the ray to lengthen it so that it will intersect the fine gradations of the counterclockwise scale. I'm just trying to line up the origin, trying to line up the baseline, and so I've got an intersection just about there, and so that is about, I'm going to have to take a look, it's about 46 degrees. Okay, so 45 degrees is about here, we're about 46 degrees. Now, let's count specifically. This is 40, 41, 42, 43, 44, well, let's do it again, 41, 42, 43, 44, 45, 46, okay, 47. So it's 47 degrees. Now, on a test, you'll never have to worry if you're 1 degree off because we know protractors are only approximate. Okay, so in general, you've got to get within about 1 or 2 degrees or so, and then you're fine. So we've got ourselves about a 46 to 47 degree angle here. Now, what if you didn't want to lengthen that side? What if you wanted to not do that? If the other side is long enough, let me just show you that there's another way you could measure angles. If we turn the angle around like this, and I'm only going to do this for this one angle, just to show you there's another way to do it, and I want to use the clockwise scale. I can now line up the origin with the vertex of the angle, line up the baseline with the ray, and now read off over here. And I can see on this scale here that we're about 47 degrees, 50, 49, 48, 47. Okay, so it's about a 47 degree angle. Okay, so that would be a double check if you wanted to do that. Let's look at the next angle. So give or take a degree or so, this is 47 degrees. Let's look at our next angle. Let's go ahead and let's line up the protractor. So let's put our protractor so that the origin goes over the vertex of the angle. And now let us sort of rotate the protractor around so that we've got the baseline of the protractor is right on top of the side of the angle. And now let's look at our counterclockwise scale. Well, it looks like it's between 110 and 115 degrees. In order to find exactly how large it is, we're going to have to lengthen this line just a bit. So let's get our straight edge out. And let me just lengthen that line. Okay, and now let's go back again and let's remeasure it. Let me take the protractor. Again, line up the origin, line up the baseline, and now let's read off what we've got. And so if we zoom in really closely, we will see that we're at about, this is 110, 111, 112. So we're somewhere between maybe 111 and 112. So I'll put 112 degrees for this angle. Now you should practice with your protractor. And you should practice with lots of angles and make sure that you feel comfortable with doing these measurements. Okay, and we're going to classify these angles. 47 degrees is an acute angle, and 112 is an obtuse angle. So it's an acute angle because it's less than 90 degrees for 47, and 112 is an obtuse angle because it is greater than 90 degrees. Okay, we're going to do the next problems in the next video.